Let's look at your notes, and you have a couple problems today. So there's good news. The good news is we're on this section for 2 days. The bad news is if you're a sophomore in the room tomorrow, you have to aspire interim test. So I'm going to give everyone else a worksheet to do tomorrow. I'm going to go ahead and give it to you today if you want to go ahead and get it done so you don't have to do any homework. I am recording, but it's recording upside down. So if you want to watch this YouTube video, I don't know if you have an iPhone. I'm an iPhone girl. On your iPhone, I always have mine on lock. If you lock your screen, then you can turn the video any way you want. So even though it's upside down, you can turn your phone to make it right side up. That'd be my suggestion if you're watching this later because you don't understand. I know. So smart. Okay, so we have a couple problems we're going to work. So the whole point of an angle of elevation or an angle of depression is that when you look out in the world, you have this thing called a line of sight. Everyone has it. So elevation, where do you think you're looking? Are you looking up or down? Up. So it's like me looking up at the projector. That would be the angle of elevation. We're trying to figure out how many degrees I'm looking up or how far away the projector is from me. That's what we're going to try to figure out today. Angle of depression is like if I was at the projector and I'm looking down on all of us. So that's what we're going to figure out. Angle of elevations are the easier problems. So let's look at angle of elevation. Always tend to be the easier one. Let's look at the first example. So you're here, and this is you, and you're looking up at the top of this hill. That's why it's a giant hill. You're trying to look at the tip top. And we're trying to figure out how tall the hill is. How high is the hill? We know how far away you are from the hill. We know what angle you're looking up at the hill. We just need to know how high the hill is. Okay, so I'm going to put an X on the side that we want to know. Using this angle, is the X the opposite, the adjacent, or the hypotenuse? Using this angle, is the X the opposite, the adjacent, or the hypotenuse? It's the opposite. What is the 400? Adjacent. So what trig function do I need? Tangent. So I'm going to have tan 49 equals opposite over adjacent. So X over 400. I multiply both sides by 400. I have 400 tan 49 equal to X. I need someone to type that in their calculator and tell me what to get. 460 point what? Okay, so about 460 feet. So if you had to round, we would say about 460 feet. Okay, are there any questions on that? So we're acting like it's a big deal today with angle of elevation, angle of depression. Really, it's just more of the same old, but now Harrison has to do word problems. Okay, yay, Harrison has to draw his own picture. Number 2, find the angle of elevation of the sun. So here's my sun. I like to draw pictures. When a 12.5 meter tall telephone pole casts an 18 meter long shadow. So something, something, something. I know this is my pole. How tall is my telephone pole? Okay, and then I've got to put an 18. I'm either going to put the 18 on the hypotenuse or I'm going to put the 18 down here. Where do shadows happen? On the ground. Thank you. So I'm going to put the 18 down here because the shadow from the telephone pole would happen on the ground. Very smart. Some good common sense going on there. Okay, the angle of elevation, meaning we're looking up at something. So do I put it up here? No, it would be down here. We're looking up at the telephone pole or at the sun. Half the battle is setting up the problem. Are there any questions on how we set this up? Well, I've done it again. I hate it when I do this 2 times in a row. What have I done? Tangent again. But this one's a little harder. Why is that? because we're looking for the angle. So I'm going to have tan of x equals opposite over adjacent, and this would be the offset. This would be the adjacent. So I'm going to have 12.5 over 18. How do I kill off tangent? Now I'm going to use the inverse, so I need tan negative 1, 12.5 over 18. I need to know some sort of degrees. 34 point. I'm going to put 34.8. I'm with Darrell. So if we had to round, we would say about 35 degrees. Okay, so far we're good. Angle of elevation ones are seriously pretty much as easy as it gets for us with word problems. So you're like, Miss Compton, I can totally handle that. Now we get to the angle of depression ones. Okay, so words I want to use. Flip over. Oh wait, he's still talking. Let's talk about angle of depression. So, angle of depression, I'm going to use this picture. It's not here. It's actually right here. The angle of depression, if they ask you for the angle of depression, we're going to put it outside the triangle. But when you have two parallel lines and they're cut by a transversal, aren't the alternate, it'd be these two, aren't the alternate interior angles congruent? So the angle of depression and angle of elevation are going to end up matching. Okay, I said a lot of words that made probably no sense to a bunch of us. So let's go on to number 3. Okay, so they tell us that there's a ski run. Here's the skier going down the slope. Not something we have around here, that's for sure. It's got a vertical drop of 208 yards. It tells you how long the ski yard is, and it says find the angle of depression from the top of the ski run to the bottom. Okay, so again, we have this picture. We have the 1,000, and we have the 208, but we're not going to put the x even inside the triangle. The number we're looking for, the angle we're looking for, is actually right here. That's where the angle of depression happens. That's where angle of depression. But by alternate interior angles, these two spots should match. So I'm going to end up setting it up the same way we did before. Here's my angle x, that's the opposite, that's the hypotenuse. I'm going to say sine of x equals 208 over 1,000. So x equals sine inverse 208 over 1,000. I need you to type that in your calculator. 12 point. Okay, so I'm just going to say 12 degrees is what you're telling me. Okay, this is a lot easier than the way I explained it last year. I don't know what I was thinking looking back at my old notes. So I'm so glad you have my second year geometry self, because first year geometry self made this way too complicated. Okay, are there any questions on that one? Now, if Ayana wants to make her life complicated, again, it's always a triangle. So if this one's 12 degrees and that one's 90 degrees, she could solve and that one's going to be 78 degrees. But no one's asking her to solve for that spot. No one cares about that spot. I'm just, saying words out loud for no reason. Okay. No one cares. No one cares about the 78. Okay, here we go. Got to draw our own picture. Maria's at the top of a cliff and she sees a seal in the water. So, I don't know. I'm not a good drawer. This is Maria. She has hair. Please, Maria, don't jump. She sees a seal. Yeah, I don't know how to draw a seal. I'm going to draw a shark. She sees a seal in the water. If the cliff is 40 feet above the water, so I'm going to put a 40 here. and the angle of depression is 52 degrees. What is the horizontal distance from the seal to the cliff to the nearest foot? So they asked horizontal, so they're asking for down here. Plus they asked for from the seal to the cliff. They didn't ask for from the seal to Maria. I guess I should have put my seal over here. Whoops. Okay, so we have this angle of depression. It's 52 degrees. But because they're alternate interior angles, this angle is also 52 degrees. Okay, and then now what trig function do I need? Was I given the hypotenuse? No, so which one do I need? Tangent. So I'm going to do tan 52 equals offset over adjacent. That one's the offset. That one's the adjacent. So 40 over x. I multiply both sides by x. I have x tan 52 equals 40, and by now you've done enough of these 40. You've done enough of these in your head that you realize you take your number, 40, and you divide by tan of your angle, so tan 52. So what is x divided by 40? X. Jeez. Thank you, Kevin, for just humoring me anyway. 31.1? 25, but it said to the nearest foot, so I'm just going to say 31 feet. Okay, let me zoom out on that. Are there any questions about this? Okay, so Harrison's prepared. I'm going to hand him a worksheet. He's going to have to draw his own sun, his own cliff, his own whatever. There might be an airplane. It's kind of obvious of who's in the sky and who's on the ground. He's very smart. He's got that. But there is a way that we can make this complicated. And it happens on number 5, and then we'll do one more after number 5 to see how it could get super complicated. Okay, so it says, and it's a long paragraph, and I did think about you and your attention span when I made the worksheet. So there's only one with a 4 sentences. Haha, only one. Okay, so it says something about a diving competition so I need a diving board. And a 6-foot tall diver, here he is. He's 6 feet tall. He stands atop, let me make the ladder and everything that he climbed up. He stands atop a 32-foot platform. And then it tells you the front edge of the platform projects 5 feet beyond the end of the pool. So meaning his diving board is hanging over that pool 5 feet. That kind of makes sense. Obviously, we want him to hit the water, not the concrete. The pool itself is 50 feet in length. And then a camera is set up at the opposite end of the pool, because that's what cameras look like. At the opposite end of the pool. And it is even with the pool's edge. If the camera is angled so that its line of sight extends to the top of the diver's head, so somehow I'm taking a shot of that diver's head. It asks, if the camera is angled so the line of sight extends to the top of the diver's head, what is that camera's angle of elevation? So we're looking for that angle down here. So that what is the angle of elevation to the nearest degree? Everyone agrees my picture looks a little complicated, but I did everything it asked for in the problem. But let's make it a little simpler. So Kevin and I agree I've got too much going on. I need a triangle. So I'm going to simplify my picture here. I have a triangle. I'm looking for this angle. They don't tell me how far it is from the camera to the guy's head. But they do tell you how high it is from the bottom to the top of the guy's head. What number should I put on this side of the triangle? 32 plus 6 is 38, because we've got to get all the way to the tip top of his head. He was 32 feet in the air. He's 6 feet tall, so it's 38. Are there any questions about the 38? Okay, and then I need to put a number down here. And I know the pool is 50 foot long, but he's standing at the end of the diving board, so he's over some of the pool. So what number should I put at the bottom here? 45, because 50, so I did 50 minus 5 with the pool because of the diving board, and I get 45. I did 32 plus 6, and I got 38. 38. And now that I've made this as complicated as I possibly can, what trig function do I need? I do. I don't know why all my examples today require tangent. Is that a normal thing? Not really. It requires any of them. So tan x equals opposite over adjacent. So I need tan inverse. I need to know tan inverse of 38 over 45. 40.0. Okay, so it said to the nearest degree, so I'm going to say 40 degrees. You know how I was really picky about rounding? All the ones with angle, elevation, and depression tend to be to the nearest foot, to the nearest degree. If you just want to round to the nearest whole number at the end, that's fine. Okay, so are there any questions about the notes before I hand you the worksheet? So you get I'm going to break your heart. You get that I have a worksheet for today. You get that I have its counterpart for my non-sophomores for tomorrow. So my poor, precious, precious sophomores have 2 mammy jammies. Can Harrison fly through these? Yeah, he can. Okay, but there is good news in that I'm going to help Harrison set up the hardest mammy jammy. Does everyone just want them both? I assume that was the case. To get it out of the way. One was this in my mind. This was for today. This is for tomorrow. But I'm going to give Darrell both because, well, he's this freshman, so not Darrell, but bless. Who's the sophomores? Bless Ellie's heart. She's a sophomore. So, ha 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 ha. If you're on my list of names, you have test tomorrow. Ha ha. Yes, Aspire test. Last Aaron test. I need to stop my recording. No one else needs to hear all this, guys.